A-Level Paper 3, June 2019. Sodium thiosulfate reacts with hydrochloric acid as shown below. Give the simplest ionic equation for this reaction. So the important parts are the sodium thiosulfate. So I've got sodium thiosulfate here, Na2S2O3. I know that sodium is in oxidation state +1, and there are two of them, 2 + 1, so the S2O3 must be 2-. It's an ending, so Na is the beginning, S2O3 2- is an ending, so it must react with the H+ of the HCl. So I must have S2O3 2-, H+ of the HCl. What I'm going to make, what does the S turn into? Well, it turns into sulfur dioxide and sulfur. And what can the H+ and the O's turn into? Water. So I've just picked out these three things here. The sodium I'm not going to bother with, and the Cl I'm not going to bother with. The important parts are the thiosulfate part, and the H has got to react with it because that's a minus ion reacting with a plus ion, or an ending reacting with a beginning. And I'm going to leave these two spectator ones out. Two H's, two H+. Let's just check the charges now. 2-, 2+, no charges on the right hand side. The SO2 is a pollutant. State the property of SO2 that causes pollution when it enters rivers. It causes acid rain, so it's acidic. Equation SO2 plus H2O, and you can just work out what's made. So that's H2SO3. It's sulfurous acid. There's a common fallacy that it makes sulfuric acid. It does. It oxidizes in the air when it comes down through the atmosphere, but it actually makes sulfurous acid, H2SO3, when the sulfur dioxide dissolves in the water. Draw a diagram to show the shape of a molecule of H2O. Well, O has got 6 electrons in its outer shell, 2 bonding pairs and 2 lone pairs therefore. So the 2 lone pairs can be shown like that. You can also show them as sort of pear-shaped bulbs if you want to as well. But the 2 lone pairs repel to the greatest extent, and the lone pair to the bonding pair to the next greatest extent, and then the least repulsion is between the 2 bonding pairs. So it goes down from something tetrahedral like CH4 from 109.5 to something with 1 lone pair and 3 bonding pairs like ammonia to 107, from 109.5 to 107, down by 2.5. And then when you get 2 bonding pairs and 2 lone pairs, it comes down by another 2.5 from 107.5 to 107 to 104.5. So the bond angle is 104.5, and the explanation is that the lone pairs repel two lone pairs repel more than a lone pair and a bonding pair, which is more than 2 bonding pairs, so the bond angle is lowered to 104.5 from that in a tetrahedral, which is 109.5. The initial rate of reaction between sodium thiosulfate and hydrochloric acid can be monitored by measuring the time taken for a fixed amount of sulfur. Sulfur is a solid. It's a yellow solid. Describe an experiment to investigate the effective temperature, so I'm changing temperature, on the initial rate of this reaction. So if I'm making a solid, the easiest way to measure the amount of solid that's made is to mix it in a conical flask, put the conical flask onto a cross on a piece of paper, and measure the time taken for the cross to disappear. I'm going to change the temperature every time, so I'm going to vary the temperature each time. I'm probably going to do it in a conical flask. I'm going to start a stop clock when I mix the two together, when I add the sodium thiosulfate and the hydrochloric acid. So I'm going to put a conical flask containing the thiosulfate onto a piece of paper with a cross. I'm going to add the acid and start the stop clock. In terms of measurements, I'm going to repeat it at different temperatures. I'm going to time how long it takes the cross to disappear, as I said, because solid sulfur is made, which obscures the cross so that you can't see the cross through the mixture anymore. Keep everything else constant, that's important. So the cross is got to be kept constant, because if you use, I don't know, a pencil and then a biro and then a thick marker pen, that will change things because you'll be able to see it to vary in different amounts through the mixture. The volumes of all the chemicals and the concentrations of all the chemicals. And then you want to plot rate against temperature. Now rate is the opposite of time, because if time goes quickly, So the rate of something, if time goes quickly, so if it's a small time, if something, the cross obscures, let's say in 1 second, then the rate is very high. If something takes 60 seconds to obscure, the rate is very low. So time is inversely proportional, is the opposite to rate. So you need to do 1 divided by time to work out the rate.